Hey there folks, Mr. G here with another educational video. This is a follow-up for part 1 where we talked about analyzing data. Now we're going to look at presenting data and different ways of presenting data, in particular using graphs. Graphs are an excellent way to visualize and summarize data, as well as to help find trends or see relationships in the data that you've collected. However, it's very important to be careful when you're looking at data and different graphs, because the type of graph or the way it's graphed can be misleading. And a lot of times when people present data, they can present it in different ways that lead to different conclusions. So depending on how you graph something, you might interpret the data very differently. Let's see some examples of this. The most common way that a graph can be misleading or someone can mislead you using a graph is by messing with the axes, the X and Y axes. If we look at our first example here, both of these graphs have exactly the same data. However, if you notice here on the graph on the left here, we start at 50, and our range only goes from 50 to 62. This can lead to a big visual difference. It looks like Group A is way bigger than Group B and Group C. And that's because we've exaggerated the difference by making our graph a lot smaller, only going from 50 to 62. So we don't start at 0 and we don't go all the way up. Whereas if we look at this graph here, we can see the difference looks very small. And in fact, the difference is quite small. Only an 8% difference over an entire difference of about 50 or 60%, there is really only a small difference. This is misleading. And this is probably the most common way that people mislead you using graphs, is they change where the graph starts and ends. In the book, they call this displaced axis. So if a question ever talks about displaced axis, this is what they mean, not starting at 0. And this is usually used to make small differences appear like big differences. Here are some more examples from different websites I was able to find. Here it looks like there's a huge difference between Democrats and Republicans and independents for who agreed with some court decision. But again, this is done from 50% to 64%, so it's only a small picture. So this has exaggerated the difference between these two. Another graph here talking about how many people are receiving welfare over a number of years. It looks like it's going up by a lot every single year, this huge increase. But if we look at the start here, it starts at 94 million, goes up to 108 million. So really the difference between these two is quite small in terms of the scale here, but because we've started not at 0, we exaggerate this difference. See if you can notice what's wrong with this graph. Did you see it? It's tricky because it looks like everything's even, it starts at 0, but if you notice, we go up by uneven amounts here. This makes it look like this first jump from 0 to 8 looks big, but this next jump from 8 to 16 looks very small, even though they're the exact same size. If we regraph it using a more appropriate scale, we can see that this difference here is the same as this difference here. The word that the book uses in this case is irregular scale. So if you see that, that's what they mean. The spacing isn't even. An example of this in the real world, as you can see, the graph here looks like we've got, a fairly regular upwards trend. If we look carefully at the graph here, the first couple increments are at 50, but this one here is only 10. Then it shifts back to 50, then it shifts to 30. So it goes from 50 to 10 to 30 in different places to create this illusion of a steady straight line, even though in some of these cases, these massive jumps should look even bigger. So messing around with the scale can change what the trend of the data looks like. The same thing here is happening, but instead of on the y-axis, it's happening on the x-axis. Last year is 365 days ago. Last week is 7 days ago. And then this is current, but these are separated by the same amount on this axis here. So this is a 7-day difference. This is a 360-day difference. So again, uneven spacing can make this graph look a lot different. Another way that we can use scale to mislead is doing the opposite of shifting the axis to exaggerate differences. We can make the differences look small. By picking a large maximum value here, way bigger than the data, it makes it look like the differences in data here are quite small. But if we zoom in, if we pick a much more appropriate scale, a maximum value that's around the size of our data, we see that these differences look a lot bigger. This one was a very strange way of misleading by messing around with the axes. It might take a second to see it, but if you notice, up at the top here, we start at 0, so we've actually flipped our graph around. So when it looks like it's increasing or decreasing, it's actually doing the opposite. So it's important that you read carefully what the axes are. And you'll notice there's not even an x-axis here. So already this graph starts to look very suspicious. Another way to mislead using a graph is by messing around with the x-axis even more and reordering them. And it looks like it starts on the 28th and ends on the 9th, but all of the values here are jumbled. They're not in order. And they're ordered in such a way that the biggest ones are on the left and the smallest ones are on the right to make it look like it's going down. Another thing they've done here is they've actually changed the orders of all of the bars, so it's biggest to smallest at each date. So in this one, blue one is first, then the purple one is first, then the yellow one, then the purple one, then the orange one. And this is again to give this illusion that it's decreasing. If we reorder it so all the dates are correct, we see it looks very different. At a glance, these look like completely different sets of data, but they're exactly the same, so it's important that you pay close attention to what the axes are saying when you're looking at a graph. Another very common way that graphs can be misleading is by messing around with area, volume, or perspective. If we look at this pie chart here, it's tilted, and when it's tilted like this 30% looks smaller than this 30%. And that's just the way that it's tilted in the way that perspective is here. If we view it straight on, we can see these two are clearly equal and this one's a little bit larger. The book uses the term exaggerated use of area or volume. Another example here, again with perspective and volume. When we add a third dimension here to our bar graph and this perspective, 2011 looks absolutely huge compared to even something that is pretty close in size in 2010, even though these only differ by about 50%. The way this perspective is drawn, it looks like this one's way, way, way bigger. And same thing with 2012. 2011 is 3 times larger, but based on this picture, it looks like it could be 4 or 5 or even 6 times as large. So anytime that graphs are on an angle like this, or you're getting an extra volume dimension here, it can be very misleading. Same thing with this graph here. Really, this should just be like a regular bar graph, like this one is over here, but they've exaggerated the area by giving it width here. So even though iron is the biggest one, it looks way bigger. Even though it's only 50% larger than this copper is, and even though zinc is a third the size of iron, it looks like it's much, much, much smaller based on this diagram. So if you see graphs that are at perspective here or have some weird thing where they're messing around with the different areas instead of doing regular bar graphs or regular pie charts, that's definitely a red flag. Exaggerated use of area, displaced axis, as well as regular scale are the 3 main things that the book focuses on when it comes to misleading graphs. However, there are a lot of other ways that graphs can be misleading. Another common way is that they use the wrong type of graph. In this diagram here, we have a line graph. And when we have a line graph with all the dots connected like this, it suggests that there's some sort of connection, or maybe an order or a sequence, but as we can see looking at our axis here, there's really no relationship between apples, pears, bananas, and peaches and how many that they sold. So a line graph here is not the right type of graph to use because there's no connection between them. There's not an order either. This suggests that the apples, then the pears, then the bananas, then the peaches. Here's another example. Imagine that you were looking at what percentage different teams got correct on a challenge. So let's say Team A got 50% of the questions correct, Team C got 38%, Team B got 64%. This is not really what you would use a pie chart for. Pie chart is part of a whole. If these are individual scores on some sort of test, then it doesn't belong in a pie chart. Instead, a bar graph would be a much better way of summarizing the data. Another way that can be misleading is if there's an incomplete amount of data. Imagine you were tracking bathing suit sales, and you'd see that, oh wow, look at these bathing suit sales. They're going through the roof. It's such a huge increase. But then you look down at the axis here and see this is only from May to August. And of course you'd expect bathing suit sales to increase here. People are going to go out to the pool. Instead, a much better picture would be to look at many years at a time. But even this one isn't a great picture because it's a very short time frame. If you were interested in investing in bathing suits, maybe you'd want to look at years before this and see if there's a better trend that you can follow. Our last category here, I'm going to call just plain wrong. Sometimes people just screw up the way they graph their data, and it's important to be on the lookout for that. For this one here, we see we've got a pie chart, but these pie charts don't add up to 100%. So somehow people are at the same time supporting different political candidates, which doesn't make any sense. So clearly these numbers are wrong, something's gone wrong here. Another example here, we see we've got this data being plotted along here, and the general trend looks like it's going up, like it started a little bit lower, but then it's gotten a little bit higher recently. But if you notice this last data point here looks pretty much on the same level as it is here. If we regraphed it though, we would see that it's a lot lower. And this graph here looks visually a lot different than this graph here. So be on the lookout for incorrectly graphed data, because that can be really misleading as well. That's the end of our second video here on misleading graphs. Take a look at the homework and the weekly assignment, and I'll see you in the next video.